Hello guys, welcome to this video. In this video, we'll be implementing one project called AutoCode Analyzer. So here we'll be implementing a system that will take a GitHub URL of any source code. Let's say you have created a GitHub repository and you have your project. So you can give that URL and this system will try to analyze your source code. And you can even let's say do the query on top of your source code. Okay, let's say you have written one function but you don't know what this function does. So what you can do, you can ask the query. Okay, it happens, let's say whenever you are looking for any kinds of other repository. Let's say we're looking for LangChain repositories and you don't know what this function does in LangChain. So definitely this system will try to help you to understand like what they are doing, how they have written the code. Every information this particular analyzer will give you. So this is going to be one amazing project, guys, because I usually use this project a lot whenever, let's say, I want to understand any kinds of implementation from any third party, let's say, developer. This system helps me a lot. So I'll show you the entire development, guys, end-to-end development. Even I will also show you how we can deploy this kinds of project over the cloud platform. So let's start the implementation, guys. Okay, I'll show you the step-by-step procedure. Even I will also discuss the architecture diagram, how we are going to develop this particular project. So here I'm going to create a new repository and I'm going to name it as end-to-end source code analysis generative AI. Fine. So let's keep it as public repository. I'll select the readme file and I will also take the git ignore wise python. Then let's take the license. I'll take MIT license. Now let's create the repository. So after that, I have to clone it. So I'll copy the link address. I will open up my local folder and here I'm going to open up my git bash. Now let's write the command git clone and paste the link. That's it. See, it has cloned the repository. Okay, now I want to go inside this repository. I'll just write cd, that means change directory, to my end-to-end, okay, source code analysis. Now I'm inside this folder. Now inside this folder, let's open up our VS Code. So let me open up my VS Code. So here is my VS Code. So guys, I think you remember the first thing, we create a virtual environment, okay, for a new project. So let's create a virtual environment. For this, you need to follow some of the commands. So let me mention in the readme file. So you can see these are the steps we have to follow. So first of all, if you're using my repository, first of all, clone it, then try to create an environment with the help of Python 3.10. So the environment name is LLM app. So for me, what I've done, guys, I already created the environment in my system. So I'll just activate the environment. But for you, if you don't have the environment, just try to create it. So let me show you my environment. I'll just write conda activate LLM app. See, it is already there for me. Okay. Now the next thing what I have to do, I have to set up the requirements of the projects. Okay. So for this, I'm going to create a file called requirement.txt. Inside that, I'm going to mention all the requirements actually I need. So you can see, guys, these are the requirement I need. I need OpenAI, TikTok, and ChromaDB. So vector DB wise, I'll be using ChromaDB. Previously, I used Pinecone. You can use any of the vector DB. It's up to you. Then LangChain, Flask. So the front end implementation wise, I'll be using Flask framework. Then Git Python. Why Git Python? I'll tell you. Whenever I'll show you the architecture diagram, this part would be clear. Then python.env just to manage my credential. Okay. And I'll be using OpenAI large language model. You can also use Gemini. You can also use open source large language model. But I told you, if you're using open source large language model, you should have good configuration machine. Okay, otherwise you won't be able to execute. And that part we'll be learning in the LLM ops, right? Now let me save everything and let me install all the requirements. So for this, you can execute this command. So let's copy the command and here I'm going to execute. See, for me, I already installed all the package. That's why it's telling requirement satisfied. But for you, it will take some time. Now, the next thing, what I do, guys, usually I create a template file. I think you remember, project template file. So templates.py. Okay. And previously, I shared one template code with you. I think you remember. So I'll just copy paste the same code. So if you missed out my previous implementation, guys, please try to check the end-to-end medical chatbot implementation. So there I already explained this code. Okay, this code, how we have written and all, everything I explain in detail. Okay, see, I'm using the same code, same actually template code. Now what will happen, this code will automatically create the template for me. So I already created requirement file. I don't need it. I'll remove it as of now. Okay, now everything is fine. So now if I execute this template.py file, see, it will create my folder structure. So let's see. See, it has created the folder structure. And whatever log actually you have written, it is showing in the terminal, you can see. Okay. So my folder structure is created. Now what I will do, I think you remember, first of all, we perform the notebook experiment. That means we'll be implementing the entire projects in our Jupyter notebook. Then we'll try to convert as our modular coding. Okay. So for this, I'm going to open the resource folder. Inside that, inside resource folder, I'm having one Jupyter notebook file called trials.ipynb. So here, first of all, let's select my kernel. So this is my environment. Okay. Now let's test whether it's working or not. So give okay message here. Yeah, so everything is working fine. Now, first of all, let me show you the project architecture diagram, like what we are gonna perform here. So guys, as you can see, this is the entire project architecture. So here we'll be basically performing question answer over the code base to understand how it works. See what happens actually whenever, let's say, we implement any kinds of project. Okay, let's say previously, I think you remember, we implemented one project called end-to-end medical chatbot. And this is the code base we have created, right? This is the entire repository of our project. Now, let's say if anyone new to this field, if actually he's not able to understand this project like how I have written, let's say this person will open this project. Let's say he will open this helper.py. And now he's not able to understand what is this function actually, download Hugging Face embedding. Or let's say, what is this function load PDF file and all. Okay, let's say anything actually he's not able to understand about the project we have implemented. He's not able to understand the code we have created, right? So what actually this application can do, so if you give this GitHub repository link to our software, my software, what it will do, it will try to first of all extract all the code from the repository. Then it will create a knowledge base. Okay. And with the help of large language model, it will try to understand what you have written. Let's see now if you're asking any kinds of question, let's say what is SRC? Inside SRC, let's say you are having helper.py. Now, let's say you are asking, let's say what is text split function, what it does. So this model will try to read this code and it will able to give the like answer. This function does this thing. And that is how actually it is working. Okay. That means it will give you the entire explanation of the code you have created. Okay. So this is called actually source code analysis. Okay. Now I think you got it. What is the project actually we are implementing? So project name is source code analysis. So basically here we'll be performing question answer operation over the code base. Okay. To understand how this code works. Okay. And this is the entire diagram you can see, guys. Let's say you are having a source code. That means a complete GitHub repository. Okay. That means the complete, let's say, end-to-end implementation. So first of all, what you have to do, you have to first of all, let's say extract all of the source code. Okay. Then you will be creating actually chunk. Okay. Different chunks. For this actually we'll be using something called context aware splitting. Okay. Now I think you can see here, we'll be using something called context aware splitting. So here is the context aware splitting, and how context aware splitting works. So let's say this is your entire source code. And I think you know inside Python programming, we use functional programming, OP programming concept, right? So let's say you have created different function. I think I told you I had created different function. Let's say this is one function. Let's say this is one example, def4. Let's say this is the function. Inside that you are having some code. Now after doing this context aware splitting, what it will do, it will first of all extract all of the source code. Then it will create different chunks. Let's say inside this function you are having let's say 200 line of code. Okay, 200 line of code. Now let's see if your chunk size. Okay, chunk size. Let's say you have given or let's say I can write 20,000 lines of code. Okay, now let's see your chunk size you have defined 500. Okay, 500. That means what it will happen, 500. Okay, 500, let's say what that means 500 these kinds of actually tokens would be considered as your one chunks. Now just try to consider how many chunks it will create. It will create different chunks, obviously. Let's say this is the first chunks, this is the second chunks, this is the third chunks. Let's say it has created 3 chunks. Okay, 3 chunks it has created. Now how your model will try to understand whether these chunks, the entire chunks, so it is related to this particular function. Let's say there would be so many functions, there would be let's say thousands of functions. But how your model will understand these 3 chunks I got, this chunks is related this function, def2 function. So what context aware splitting will do, it will automatically tag. So see, it is automatically tagging. So this is the chunks of def2 function. Okay, let's say you are having another function, let's say def test. Okay, this is the function. Inside that you have subcode. First of all, it will perform this splitting, that means chunking operation. You will get different chunk. Okay, then it will also perform the tagging operation. Let's say this is the tag of test function. That means your model will try to automatically understand now. Now your model will try to understand, okay, this chunks actually I'm getting, this is related to this particular function. Okay, so that's how actually it will understand the context, it will remember the context. Okay, this is called actually context aware splitting, and this context aware splitting we only perform whenever we are working with let's say code, okay, code data, because previously we work with text data. Okay, text data is a different thing and code data is a different thing. That's why you have to follow this thing. Okay, now let me clear my screen. Now see what will happen. You have to create a vector store, yes or no. You can see after actually getting all the text, okay, all the chunks, you will be using embedding model. With the embedding model, you'll be creating vector store, and here we'll be using something called ChromaDB. Okay, ChromaDB will be using. Okay, then this would be your knowledge base. Okay, and you'll be connecting your large language model. After that, whatever question actually user will ask, okay, let's say this is the user, whatever question user will ask, it will take this actually relevant answer as well as the question. It will try to understand. Based on that, actually it will give you the actual response. Okay, so this is the entire application we'll be creating. And again, you can see here we are implementing something called one RAG application, retrieval augmented generation. Okay, because here we are feeding our custom data wise we are using code data. Okay, our let's say source code we are using here. So I hope now it is clear. Now let's start the implementation, guys. So first of all, let's implement everything in our Jupyter notebook, then we'll try to convert everything as our modular coding. Now let me clear my screen. Okay, so first of all, let's import all of the library I need. So here you can see I have imported all of the library actually I need in this implementation. Now the first library I'm importing called from git import repo. So I think you remember we installed one package called git python. Okay, so what is git python? Git python is nothing but this is the package like git GitHub. Okay, this is the GitHub actually package inside Python. That means with the help of this package, you can clone any kinds of repository from the GitHub. Let's say the way actually cloned. I think remember we open up our terminal, we just written one command git clone, then we pasted that link, right? We pasted our repository link. I think remember. Okay, and it was able to clone this repository in my system. So now if I want to do with the help of Python programming, how we can do it? For this, we'll be using this package actually git python. Okay, so with the help of that, we'll be easily cloning any kinds of repository from our GitHub, because I told you now user will upload one URL. Okay, that means GitHub URL, project URL, and from the URL actually it will automatically, let's say, clone the repository, then it will extract the information, that means your code base, then it will perform the chunking operation, embedding model, store the embedding in the knowledge base, then it will connect the LLM. Okay, that's how we'll be performing the entire operation. Got it? And here I'm also importing another package called language, because here we'll be using programming language. So I'm going to use Python programming. So with the help of language, actually I'll try to use Python programming language here. Then generic loader, language parser, recursive character text splitter. Okay, so these are the actually additional package I'm also importing, and I'll tell you whenever I will be using them, I'll tell you each and everything. Okay, why I'm using it and what is the use of it. Now you can see I'm importing OpenAI embedding because I'm going to use OpenAI embedding model. Then ChromaDB vector database, I already told you. Then we'll be creating our chain. Okay, the complete chain, and here we'll be using actually memory, conversation summary memory, because I think you remember in our LangChain series actually we learned how to create the memory. Okay, like it will remember your previous context. So with the help of this conversation summary memory, we can also create a memory buffer. Okay, so this thing actually we have imported so far. Now let me execute. Now see, it should work fine because we have installed everything. Now the next thing what I will do, guys, I'll just create a folder here. So mkdir. So this is the command to create a folder. I'll name it as test repo. Okay, test repo. Now see, if I show you my project working directory right now, so pwd project working directory, I'm inside resource folder. So inside resource folder, it will create a folder called, okay, mkdir is not recognized. Okay, so it should be mk, okay, not mac. Now it should work. See, now in the test folder, it has created one folder called test repo. Inside test repo, I'm going to clone the repository. And to clone the repository, guys, you can use this code snippet. So here I'm using this one actually, I think remember, a repo. So the repo actually I have imported from Git. So inside that, you have one function called clone from. Now you have to mention the URL, like which repository you want to clone. Let's say I want to clone this medical chatbot repository. I've given the entire link. So this is the link I have given. Just copy the link and try to mention. Here you can give any kinds of URL, any kinds of GitHub URL you can mention here. That repository would be cloned. Then after that, you have to define the path. In which path you want to clone? I want to clone inside this particular path. Okay, this folder. Now see, if I execute, it will automatically clone this repository inside the test repo folder. Let me show you. Execution done. Now inside resource test repo, see, it has cloned all the source code. See, all the source code you can see it has already cloned. Okay, amazing. Now the next thing will be loading all the codes. Okay, all the, let's say, codes, all the data from this repository itself. Okay, all the Python file will be loading. That means we'll be extracting all the source code. For this, I'm going to use this code snippet. So here is the code snippet, guys. So here I'm using generic loader from file system. So I think remember we imported this generic loader from LangChain. Okay, generic. Now here I'm giving the repo path, that means where my repo is present. Then I'm giving the globe, that means it will open, that means it will extract all the Python file, okay, .py file. Then parser, you have to mention the language. So here it is the Python language, okay, that's why you have to give the Python language. And parser threshold, you just keep it this particular number 500, okay, this is the default number, you can keep it. Now it will give me the loader object, okay. Now from the loader object, I will load the documents. Now see, it will give me the entire documents right now. If I show you, see, all the content is as extracted, okay. Now if you want to see them, now how many documents you got, you can check the length of documents. You'll see that 7 documents actually I got. Now if you want to see any kinds of specific, let's say, documents, you can print it. Now you can see this is the entire source code. You can see it as extracted, okay, from my repository itself. Now the next thing, guys, will be performing this context aware splitting. Okay, context aware splitting, I already told you, we'll be creating the chunks, and this particular chunks will tag with the function name. For this, we'll be using this this particular code snippet. Let me show you. This is the code snippet, guys. Recursive character test splitter you can use, and inside that you only need to mention one parameter called language is equal to language.python. So it will automatically perform the context aware splitting. That means it will tag the chunks with respect to the function. Got it? And chunk size and chunks overlap I have given. Now let me execute. Now I'll apply on top of my entire documents. Okay, document splitter, split documents. I'm passing my documents. Now it will give you the entire chunks. So let me show you. So this is the chunks I got. If you want to see the length, you can also see the length. Okay, see, this is the length of my chunks. Got it? Then next thing what I have to do, guys, I have to actually use the embedding model. Okay. To convert all my source code to the embedding representation, and I will be storing to my knowledge base, that means ChromaDB. For this, I will be using OpenAI embedding model, I think, remember. So let's set our OpenAI environment API key here. So this is my OpenAI API key. So I already created and I already set here. Now let me save. I'll go back to my notebook. Now, first of all, let's load this API key with the help of .env package. So here you can see I'm loading it. Then I will set this API key as an environment variable. Then I'm going to initialize my embedding model. Okay, OpenAI embedding model. That's it. Now let's initialize my ChromaDB. So I think you remember we imported already Chroma from LangChain here. So Chroma we already imported. You can see vector store Chroma we imported. Now inside ChromaDB, we are passing our text. That means the chunks actually I created, and the embedding model as well as the parses directory. That means it will create a directory. That means database. Okay, so instead of data, you can give database. Okay, DB. Okay, DB. So it will create a database, like local database. Inside that, it will save all of your embeddings. And ChromaDB session I have already taken in the YouTube channel. You can check it out how ChromaDB works. Okay, now let me create the vector store. Now see, DB has created. Okay, inside resource, and it is converting all the code to the embedding representation. And it is saving inside DB. Now see, it has created the local database. Okay, see. Okay. Now what I'll do, I'll just make it as, now to activate this vector DB, you have to execute this line, vector db.persist. Okay. Now I'll be initializing my large language model. So here you can use any kinds of large language model. You can also use GPT-4. I'll be using the default model like GPT 3.5 Turbo. So let's initialize my LLM. Then I'll be creating the memory. That means that history memory, conversation summary memory. You can see I'm importing this library. And inside that, I'm passing my large language model. Then memory key is equal to chat history. That means it will remember my previous context. Okay. Then return message is equal to true. So this is going to be my memory object right now. Then I'll be creating my final chain. So for this, you'll be using a conversation retrieval chain. Okay. Now inside that, give the LLM retriever vector database. Okay. And as retriever, so search type, I'm giving MMR keyword. It will give me 8 relevant answer. And here I've given the memory. Okay. Now this is going to be my key object right now. Now let's ask one question. So I'll prepare one question here. Question is equal to, let's say, I'll go to the test repo. Inside that, I'm having src folder. Inside help part, I'm having one function. Let's say download Hugging Face embedding. I'll copy this function name, and here I will ask what is download Hugging Face embedding function. Okay, let's see whether my model is able to explain or not. So this is my question. So this question I'm going to pass inside my keyword, that means my chain. Okay, and it will give me results, and I'm going to only extract the answer, okay, from the result itself. Now let's see. So guys, you can see I got the answer. The download Hugging Face embedding function downloads the embedding from the Hugging Face model. So this is the model actually. Okay, now see if I open it up. See, it is correctly identified. This model actually we are trying to download, and which returns embedding of 304 dimensions. These embeddings are used for the processing and analyze text data into context of the application. That means correct information. Okay, amazingly, it has explained this function. Now you can give any other question. So what I will do, I'll copy this question and let's ask about this function right now. Let's say I'll ask about load PDF file. Okay, this function right now. Let's see what it will give me. So I'll copy the same code. And here I can mention, I think. Now let's see. So ignore this line. Okay, this line is not required. So this is your actual response. The load PDF function loads the PDF file from a specified directory using directory loader class, which is a filter of PDF files. And then it extracts the documents and return the items. Amazing, guys. So that's how you can perform the QA operation with your code base right now. If you don't understand any kinds of code, if you don't understand any kinds of function, just try to, give it here and try to ask it. So it will give you the entire explanation of your code base. Okay, this is called actually source code analysis. And this is one of the amazing project, guys. Amazing project. Got it? Now, this is the actually notebook experiment. Now let's try to convert this project as our end-to-end implementation. Okay, so I'll just do the copy paste operation from my notebook only, because I think I showed you in my previous implementation, I did the same thing. So now what I will do, guys, I'll open up my SRC folder inside helper. So whatever, let's say, code I have written, okay, then let's say individually, I was loading the, I was cloning the GitHub, I was extracting the data, I was performing the embedding model operation. Okay, so everything I'll just write as a function inside helper.py. Okay, so now let's do it. This is how actually I implemented, guys. So I'm importing all of the necessary library. Then first of all, I created one function called repo ingestion. It will take the repo URL and it will do the ingestion operation. That means clone operation. The same thing we are doing in our notebook only. Got it? Then second function I have written called load repo. The same code, guys. That loader, generic loader I'm using here. See, it will take the repo path and it will load the, let's say, code, and it will give you the documents after extracting. Then the third function I've written called text splitter. That means it will perform the context aware splitting. Okay, the same thing. Then it will give you the embedding model. Okay, it will first of all get the embedding model from the OpenAI. It will return you. So instead of actually writing the scripting, I've just written as a function. That's it. Now the next thing what I will do, I'll add everything inside my endpoint, which is nothing but my app.py, because app.py user will execute and they will get one user interface, and from there actually they will upload, let's say they will give the URL, they will do the QA operation. Okay, so for this actually I already told you we'll be using Flask, and for the Flask actually you need one template and a static file, I think you remember. So let me show you. I already prepared one HTML and CSS code for you. So guys, as you can see, this is the template file, and inside that I'm having one index.html, and this is the HTML code. And again, I refer the internet bootstrap website to implement this actually HTML and CSS code. If you're not aware about, it's completely fine. You can use my template as it is. Okay. Now inside static folder, I'm having the CSS. That means CSS code. Okay. That means style of our web interface and all. And to execute this style.css, I am using some JavaScript actually code. You can see this is the JavaScript code. Again, I got it from the bootstrap website. Now see how your application will look like. I'll tell you. Before that, let me write this app.py code. So inside app.py, I'm going to import all of the library I need. So you can see I'm imported all of the library like ChromaDB, load embeddings, okay, from the SRC helper, because I need the embedding model, right? Then repo ingestion, I'm also importing from the SRC. Then my chat OpenAI, okay, function, then conversation summary, okay, conversation retrieval chain. So everything you can see in the notebook, I'm importing all of them here. Now, first of all, what I have to do, I have to initialize my Flask, and I will set the OpenAI environment key as my environment variable here. That's it. Okay, see. Now, first of all, I will load my embeddings, okay, from my vector database. You can see I'm loading the embedding from my vector database. So for this, before that, what I have to do, I have to first of all generate the vector embedding. Let's say if user has given the URL, so it will generate the embedding, right? It will create the embeddings and it will say inside my vector database, yes or no. So for this, I'm going to create another file called store_index.py. So previously in the medical chatbot implementation, I written the same file, I think, remember. Inside that, I was doing the actually embedding storing operation. See, so you can see repo ingestion, load URL. So I'm importing everything. I'm setting my OpenAI API key. Then load repo. That means, see, user will give the URL. So this URL actually repo ingestion will load, and it will load the, let's say, documents. It will perform the text splitter embedding. Then this embedding will store inside my like ChromaDB. ChromaDB will create an like local database. Inside that it will save everything. Okay, I think you remember. Now here I've commented this 2 line because I will be doing this thing with the help of user interface. That means UI. Okay, not manually actually. So that means from the app.py user will give the URL. Okay, from the user interface, web application user will give the URL. This URL I will receive here. Okay, I'll receive here, then I will execute this line of code. Okay, so that's why I've commented this line. But if you want to test, what you can do, you can uncomment it and you can execute this line. You will see that it will work fine. Okay, so as of now, I've just commented out. Now let me save it. Now I'll go back to my app.py. Now let's create the LLM chain. So this is the chain. The same code I've copy pasted from my notebook, guys. I'm creating the LLM, creating the memory. After that, I'm creating the QA chain. That's it. Then I'll be creating 2 route. Then I'm going to create a route actually from my Flask. So this is the default route. First of all, it will render the index.html whenever user will open the application. Okay. Then the second route I'll be creating for the repo ingestion. So whenever user will pass the URL of the GitHub and they will submit. So what will happen? It will execute this store index.py. You can see I'm executing this command, python store index.py. And if you want to execute any Python file, that means if you want to execute any command, you have to use system, voice.system. You can see I've imported operating system. So voice.system, and inside that just give the command, it will execute this file. That means what will happen? Whatever URL user will give. Okay. So first of all, it will perform the repo ingestion. I think you remember we created the repo ingestion function. Repo would be ingested in the repo folder. And if I go it back, now see, now it will execute this store index.py file. That means this file. Now this code will be executed. That means it will load the repo, extract the documents, create the chunks, load the embedding model, then store all the embeddings to the knowledge base. That means inside my ChromaDB vector database. Okay. Now I think you got it. Now see, this is my second route. Now I'll be creating another last route. This is for the chat operation. That means after ingesting the data, creating the knowledge base, it will perform the chat operation. User will give the message. Okay. And if message is equal to clear, it will remove your let's say entire repository. That let's say you want to clone another repository, so your previous repository should be deleted. Okay, otherwise what will happen? It will take all I mean space. Okay, in my system. That's why I'm removing it. I'm doing the you can say rm.rf operation. That means it will remove it. So this is a Linux command. That's why I'm executing inside voice.system. Okay, then after that, whatever input user is giving, I'm getting the results. I'm rendering the answer. Okay, that's it. Now let's open up my application and let me show you. Now I think this part would be clear. So I'll open up my terminal. Now let's execute my app.py. So app.py will open. It's running now. Let's go back. Now just search for localhost port number 8080. Now see, this is the interface of your application. Okay. Now here you have to give the URL. So I will give this URL. I'll just give it here. Now see, I'll just send it. Now see, in the backend, what will happen? It will ingest. That means it will clone this repository first of all. After that, it will create the embeddings and it will save this embedding in the vector database. Now see, internally everything is executing. If you go here, now see, repo, it is cloning as well as DB would be also created. Now let's wait and let's try to see. So guys, as you can see, my execution is done. So if execution is done, you will see this message actually, response. Okay, response. So now if I open it up, now see, my repo has ingested and also my DB object is created. That means my embeddings has already stored here. Now I can perform the QA operation. For this, I'll be using this template right now. And this is the same actually chatbot template I'm using from my medical chatbot. Okay. Now here you can give any kinds of question. Let's say I'll give what is. I'll ask the same question again. So I'll open the repo src helper. Let's say I'll ask this one, download Hugging Face. Like what is this function and all about? Function. Let's see. See, this is the answer I got. The download Hugging Face embedding function responsible for downloading the embedding model from the Hugging Face called sentence this model and specify return the 384 dimensional vector. Great. Now I'll ask another question. What is this function? Let's say text split. See, text split function. See, text split function purpose is to split the extracted data into smaller text chunks. This text chunks are useful for the processing and analyzing the text in a smaller, more manageable section. Great. That means it is giving you the correct response. Now you can ask any kinds of question regarding your source code. Okay. So this is the entire implementation, guys, of our project. Yeah. So I think you liked it, guys. And in the next video, we'll see the deployment, like how we can deploy these kinds of projects, okay, to the like cloud platform. So for this section, we'll be using AWS. So in AWS, I'll show you the deployment part. So before ending the session, first of all, let me commit the changes in my GitHub. So I don't want to push the repo. Let's say this repo I don't want to push. So what I can do, see, let me show you another thing. Let's say if I give clear message here, it will remove the repo folder automatically. See, repo folder would be deleted because you have written the code here. I think, remember, inside helper, not helper, I think inside app.py. See here, if you give the clear, it will remove the repo folder. Okay. Now if I click here, now see, then I also don't want to push this DB objects. What I can do in the git ignore, I can mention this DB. Let's say DB would be ignored. Inside everything, just try to ignore. Now let's try to see. DB is also okay. Another actually repo I'm having inside resource. So let me also mention resource also. Inside resource, I'm having test repo. So everything I want to ignore, as well as I want to ignore the DB as well. Now I think, okay, research spelling is not correct, so it should be like that. Okay, research. Now let me save. Now see, it is ignoring everything. Okay, now let me push the changes. So I'll just write updated, commit, and seeing the changes. Now if I get back and refresh here, see, all the source code has been updated. Now let me write the further step you can perform. So here I've added the next step, like you have to create the environment file. Inside that, just set your OpenAI API key and just run app.py, and you can execute your project. Okay, that's it. Now let me also update this readme file. Readme updated. Now let's refresh here. Now see, everything is mentioned. Okay, all of the command I have shared with you. Now we'll try to see the deployment part, like how we can deploy these kinds of projects on the cloud platform. If you want to learn any other cloud deployment, it is also fine. See, the process will remain same, only the cloud functionality would be different. So I'll try to create some more video on the deployment. Like I'll also show you how we can deploy these kinds of project on the GCP cloud, on the, let's say, the Azure cloud. But first of all, let's try to see how we can deploy this project on the AWS cloud. And see, this is not going to be a simple deployment. So here we'll be doing continuous integration and continuous delivery or deployment. That means CI/CD. So I think you have heard of this particular term called CI/CD, right? So we'll be learning how we can deploy this project as a CI/CD. I think you already know how to deploy any machine learning project, deep learning project as CI/CD, but we haven't seen how we can deploy any kinds of generative AI based project as a CI/CD, right? So that's why make sure you are watching this video till the end. So here I'm going to show you each and every step you have to follow. And trust me, if you follow this step, guys, you can use this step to deploy any kinds of, let's say, generative AI based project. Okay, and this is going to be production grade deployment. Okay, so here I'm going to use different kinds of service from the AWS. Even I'll be also using Docker. That means first of all, we'll be Dockerizing the entire source code. Then we'll be deploying this application on the cloud platform. Okay, so make sure you are watching this video till the end. So before starting the deployment, guys, first of all, let me show you what exactly we're gonna perform here. What is CI/CD exactly? Then I will also discuss, let's say, what are the tools and technology we'll be using here, what are the services we'll be using here. Then I will start with the deployment, and make sure you have the AWS account. If you don't have the AWS account, guys, so you won't be able to deploy this project. So first of all, try to create one account. If you're creating for the first time, you will get $300 free credit. Okay, and this is enough for you. So try to create an account, guys. Then you can start with the deployment with me. So let's open up our Blackboard and try to see the architecture overview. So guys, as I already told you, here we'll be doing something called CI/CD deployment, right? And I already told you what is CI/CD full form. It's continuous integration, continuous delivery, or deployment, right? So inside continuous integration, continuous delivery, what happens? Let's say you are the developer. Okay, let's say you are the developer. So what is your task? Your task is to develop a project in the development, let's say, environment. So development environment means like your local system. Let's say you are using your laptop or computer. Let's say local computer. Okay, local computer. Fine. Then what we are doing, I think you remember, we are committing this code to the GitHub, right? We are doing the code management. I think you remember. That means whenever I was adding some new feature, I was pushing this code to the GitHub. Yes or no? Okay, with the help of Git client, we are pushing the code in the GitHub server. Now what happens actually, let's say after deployment. So this is called actually development server, or I can write this is actually development environment. Okay, development environment. So after implementing this project, what we have to do, we have to deploy this project, yes or no? Let's say somehow you have deployed this project on the AWS cloud. Let's say this is your AWS cloud. Fine. So let's say you have deployed this project to the AWS cloud manually. You just created a, let's say, instance there. You just took a machine there, a EC2 machine, and you manually deployed this project. Now it will give you some endpoint. Okay, endpoint. So with the help of this endpoint, any of the user, okay, user can access your application. Now let's say after 4 months or let's say 6 months, you want to add some more features in this, let's say, application. Let's say you are deploying medical chatbot. The medical chatbot we implemented, I think you remember, right? Let's say you want to add some more data, you want to add some more knowledge base, and you want to add some more features in this application. Then what you have to do, you have to again develop this, let's say, features in your code. Then what you will be doing, again, you will be deploying this application to the AWS cloud. Now just try to see, whenever you are deploying the project for the second time, let's say this is the first time you have deployed, then you are trying to deploy for the second time. Then what you have to do, first of all, you have to stop this application in the AWS. Okay, stop this application. Then you will be uploading your updated code. Then this code will reflect to the endpoint. Then user will be able to access that. Now let's say in between, whenever you stop this AWS server, let's say your application, let's say it took 3 hours. It took 3 hours to change the entire source code. That means change the entire features, okay, of your application. So what will happen? 3 hours user won't be able to access your application. So they will come your website and they will see server error. Okay, server error actually they will get. So if user is getting this kinds of experience, so definitely it would be a negative, let's say, effect, okay, on your application. So next time actually they are not going to use your application, yes or no? Let's say if ChatGPT is down for the let's say 3 hours, definitely people will move to the Google Bard or any other, let's say, software, whatever actually we are having. Okay, so now see, ChatGPT is also updating their, let's say, application day by day. But did you ever observe this server is down? No, you are not seeing this server is down, but still they're able to make the changes in their application. How? Because they are following something called CI/CD approach, continuous integration, continuous delivery. That means this application is keep on running, but in the backend they're pushing their source code, they're pushing their, let's say, new features, and this feature is automatically getting updated. Okay, so this is called actually CI/CD. That means you are not going to deploy this application manually. Instead of that, what you have to do, you have to follow the CI/CD. That means what will happen? Let's say you have changed something in your code, you will push the code to the GitHub. Okay, GitHub will automatically let's say deploy your code to the AWS cloud. It will automatically push your code to the AWS cloud, and your endpoint would be automatically updated. Okay, automatically updated, so that if user is using your application, okay, they won't be feeling any kinds of, let's say, server down issue. Okay, server down issue actually they won't be feeling. Got it? So this is what actually we have to do. That means we'll be creating the entire pipeline, entire, let's say, CI/CD pipeline. So we'll be just pushing the code in our GitHub, and GitHub will automatically trigger this action, and my code will update it to the AWS cloud, and AWS will update the endpoint. Okay, now see, the automated process we'll be doing. Now whenever we'll let's say push our code to the GitHub, GitHub will automatically trigger. How it will trigger? For this you have to use some CI/CD tool. Okay, CI/CD tool, CI/CD automation tool. So here there are different kinds of CI/CD tool. So the first tool you can use something called GitHub Action. Okay, GitHub Action you can use. Then you can use something called Jenkins. Okay, Jenkins. Then you can use something called Circle CI. Circle CI. So these actually 3 famous tools actually we are having in the market right now. So people are using more this GitHub Action because GitHub Action, you don't need to set up anything. It is already set up everything in the GitHub. But if you're using Jenkins and Circle CI, you have to set up this server manually. Okay, so here we'll be using GitHub Action because it is already inbuilt with the GitHub. We don't need to set up anything. Going forward, I will also show you how we can, let's say, use Jenkins, Circle CI. These are the services as well. Fine. So yes, guys, this is the complete high-level architecture of our deployment. Now let's discuss what are the services actually we'll be using for the deployment. See, here the first services actually I'm going to use called Docker. So I think you already know Docker. So Docker is a containerization service. So with the help of that, you can containerize your code. That means, let's say you are having a source code, you can perform the containerization. That means it will create a Docker image for you. Okay. So this image you can, let's say, keep anywhere. Let's say you can keep in the Docker Hub. You can keep, let's say, in the ECR, that means Elastic Container Registry. From there, you can pull the image and you can execute this image. Okay. So if you are using Docker, so you won't be getting any kinds of setup issue. This is the main advantage here. Then we'll be using something called ECR here. ECR means Elastic Container Registry. So this is the service from the AWS. Okay, AWS giving the service. So here you can store any kinds of Docker image. It is the same like your Docker Hub. Okay, but it is the service from the AWS. You can store the private image there, but in Docker Hub actually all the image would be public. This is the difference only. Now we'll be using another service called EC2. Okay, EC2 is a virtual machine service from the AWS. Again, it is from the AWS. Okay, so this will give you virtual machine. There you can buy, let's say, CPU based machine, GPU based machine. Okay, so all kinds of configuration would be there. So here we are using a local computer. So there we'll be getting a cloud computer. Okay, this is the difference only. Then as a CI/CD tool, I'll be using something called GitHub Action, as I already told you. Okay, we'll be using GitHub Action for the CI/CD management. Fine. So yes, guys, these are the services as of now I'm going to use. So let me show you the deployment step we'll be following. For this, what I have done, guys, I think you remember we implemented one medical chatbot. This is the code, and this code would be also available in your resources section. Even you will also get this code in my GitHub. So guys, this is my GitHub profile. Just search ENT in the Google, you will see my GitHub. And here I have created one repository called end-to-end medical chatbot. So I'm going to commit this code here. So you will get all the source code from this repository itself. Okay. And even I will also add the deployment step in the README file. So that is what actually I have written. You can see the entire deployment step I have written here. Now this is the CI/CD deployment we'll be following. So first of all, what I have to do, we have to, let's say, create a IAM user. Then we'll be creating the EC2 machine ECR. Okay. Then we'll be, see, this is the deployment step as of now. Just try to follow this step I'm going to show you. First of all, we'll be building our, so here, first of all, we'll be building the Docker image of our source code. That means Docker image we'll be implementing. Then we'll be pushing this Docker image to the ECR. That means Elastic Container Registry to store my Docker image. Then we'll be pulling this image from ECR in the EC2. That means we'll be pulling that image in the EC2 machine in our virtual computer. Then we'll be launching this Docker image in my EC2 machine. And from there, we'll be creating an endpoint. And that endpoint user will be able to access. Okay. And these are the policy I have to give whenever I will be creating the IAM user. Fine. So this is the entire step, guys, I have written. Even I have also given all the command you need to execute here. Now let's start the deployment, guys. But before that, you just need to prepare some of the files. The first file you have to prepare the Docker file. So this file will help you to containerize entire your application. That means it will perform the Dockerization. And these are the Docker command you have to write. So I think you remember we are using Python 3.10. Okay, this Python version. That's why I have taken Python 3.10 Slim Bastard image. Then working directory, it will create a working directory called app. Inside that, it will copy all the source code. Then it will install the requirements. Okay, whatever requirements actually we are having here. Got it? Then it will execute this Python 3 app.py command. So that means my endpoint would be executed. Okay, my application would be running. And make sure before actually deployment, you just store your index. Okay, in the Pinecone. So this is the Pinecone, guys. It is running, and all the vector is already stored here. You can see 7020 actually record is already stored here. So I already executed this file. I think remember store index. So it will create all the, let's say, vector embedding, and it will store in the Pinecone. Okay, Pinecone vector database. So in this project, I was using Pinecone. I think remember. Okay, so this should be available here. Got it? So once it is available, now what I have to do, guys, then you can create another file called Docker ignore. Inside Docker ignore, you can mention like some of the file which is not required. Let's say here this file is not required. Let's say I think this file is not required. Generative AI project.eginfo. Okay, so whenever it will perform the, let's say, containerization, that means Dockerization. So I don't need this folder. That time what you can do, you can mention this folder name in the Docker ignore file. It is the same thing as your git ignore. So it is already mentioned inside my git ignore. That's why I haven't mentioned inside my Docker ignore. Docker ignore is completely empty. As of now, I need all the file. That's why I haven't keep anything here. Now let's say if you want to ignore any kinds of file which is not required, that time you can store these are the file inside docker ignore. Okay, that's the thing. Now the next things you have to create. You have to create one folder called .github. Okay, inside that you have to create one folder called workflows. Inside that you have to create one YAML file. You can give any name. Here I have given cic.yaml. Okay, now see, this is the complete YAML file. So this YAML file will help me to do the CI/CD deployment. Okay, that means here it will be using something called GitHub action. Okay, and GitHub action need this YAML file. So here all the command is already written. So first of all, you will see that it will perform continuous integration. Inside continuous integration, it will authenticate with my AWS account. Okay, then it will log in with my ECR. Then whatever, let's say, Docker image actually will be building, you will push that image to the ECR. Okay, that means Elastic Container Registry. Then your continuous deployment will start. Again, it will authenticate with AWS account. Then it will pull that, let's say, image from your ECR to EC2 machine. Then it will execute it here. And here all the environment variable I have set. You can see -e means this is the environment variable. See, AWS access key, AWS secret key. I'll tell you how to generate. These are the key. Then Pinecone API key, OpenAI API key, everything I have set here. Okay, so these are the thing we'll be reading from the secret. Okay, GitHub secret. I'll tell you how to create the GitHub secret as well. So as of now, just try to remember this is the YAML file you have to use for the CI/CD. And this YAML file you can use as it is. No need to change anything in your other project as well. Okay, that's the thing. Now let's open up our AWS account. So guys, this is my AWS account. I already logged in with my AWS account. So here, so first of all, what you have to do, you have to create a IAM user. So let's create a IAM user. So IAM. So the first thing we'll be creating one user here. So let's create one user. I'll create a user. So let's say username is, I'll give medical bot. You can give any name, it's up to you. So let's click on next. Now you have to give policies. Okay, like what are the policy you want to give in this user? I don't want to give my entire policy. That means all the services I don't want to give the access. So I'll be giving some specific access. So access wise, I already written in the readme file. Let me show you. So these are the access I'll be providing. My EC2 container registry full access and EC2 full access. Okay, these are the thing we'll be giving. So here just search it. So this is the ECR. Okay, ECR Elastic Container Registry full service here I'm giving. So let's select. And after that, again, I can delete it. Then I'll try to copy the next service. This is the service. Okay, this is the EC2 machine service. So again, search here and select the EC2 machine and click on the next. Now you'll see that I have given this two service. Okay. Next thing, just create the user. So right hand side, you can see one button is there, create user. Just click on create user. So guys, as you can see, my user has created. Now I'll click on the user. Then here I will get one option, security credential. Just click here. Then you have to create a access key. So click on create access key, select command line interface. And I understand this above recommendation and click on the next. So there is a next button. Just click on the next. Now create the access key here. Now see guys, this is your access key and secret access key. Try to download as a CSV file. So let's download. So and just keep it with you. Okay, this thing I need later on. Okay, and no need to share this key with anyone. Otherwise they will also access your AWS account. Okay, so here I'm showing because after the recording I'll delete everything. Got it? So my IAM creation is done. Now I'll go back to the home page. Now the next thing what I have to do guys, I have to create a ECR repository to store my Docker image. So let's search for ECR. So just search for ECR. That means Elastic Container Registry. Just open it up and make sure you check your region. In which region you are working. See, I'm working in Mumbai, AP South 1. If you're in other region, just try to note it down. Okay, you have to note it down this syntax actually. AP South 1, then CS Central 1. If you're, let's say, in North Virginia, you have to give US East 1. So just try to remember these are the tag. Okay, so I'm inside Mumbai. That means AP South 1. Now I'll be creating a Elastic Container Registry. So let's create. So let's click there. Now you have to give the name. Let's say I'll give medical chatbot. You can give any name. It's up to you. Everything keep it as default. Now click on next. Now see, my repo is created. Now what you have to do, just copy the URI and just try to paste it as of now here, because this thing I need later on. Just for reference, I'm saving it here. Okay. That's it. Now what I will do, I will go back again. Now the next thing I have to do, I have to create my EC2 machine. Then I have to set up, these are the requirements. Okay, that means I have to set up the Docker there. Then I will be also updating that machine. So let's create my EC2 machine right now. So search for EC2 here, EC2 instance. So this is the EC2 service. Now launch the instance. Now select the Ubuntu machine. And what you have to do, give the name of the machine. Let's say medical bot machine. You can give anything. Then See, instance type, you have to take at least 8 GB RAM. 8 GB RAM, just take 8 GB RAM. I'll be taking T2 large, okay, this machine. And then select the key value pair. If you don't have the key value pair, you can also create it. So let's say I'll give medical. So it will create one RSA file. So guys, you can see after creating and download, it will give you one PEM file. So this PEM file you can use. Let's say if you're using any third-party tool to connect with your EC2 machine, let's say Putty or Mobile Extreme, that time you can use this PEM file. But I'm going to launch my, let's say, machine in my second tab with the help of AWS only. I don't need this PEM file, okay? So now I'll select these two options, HTTPS and HTTP. Keep it everything as default. Configuration storage at least take, let's say, 30 GB. And launch the instance right now. So here you can see, click on view all instance. Then see, my machine is running. So if status is running, now click on the machine ID. Now here you have to connect this machine. So click on the connect button. Now I'll be selecting the EC2 connector and let's connect the machine. So it will create a new tab for me. So here I will get one terminal, black terminal. So we have to use this terminal to set up everything here. And this is the production server, guys. Okay, that's how your production server looks like. See, this is the production server. Let me zoom. Now let me clear. See, here you won't be getting any kinds of UI interface. Okay, that means the way we are using our computer, it is having UI. But in the production server, you won't be getting any kinds of UI. You have to work with the terminal always. And this is the Linux terminal I got. This is the Linux machine, guys. So that's why if you know any kinds of Linux command, it will help you a lot. Got it? So here, first of all, I have to update this machine. For this, you have to execute these at the command one by one. So let's copy all the command one by one. Okay, so this is done. Now I'll copy the next command and just try to paste here. Now give yes permission and press enter. Okay, so execution is completed. Now I have to set up the Docker in the EC2 machine. So this is the command you have to run. Copy the next one and execute. Then I will execute this one, then the last command. So we have to add the Docker in the sudo group, okay? Now, if it is running or not, so what you can do, you can execute one command, docker ---- version. So if it is showing the version, that means Docker is installed successfully. Now, we have to set up our self-hosted runner. EC2 as our self-hosted runner. That means we have to connect our GitHub. Okay, you can see this is the GitHub. Now, this is our project GitHub. So this GitHub I have to connect with my AWS. That means whenever user will, whenever let's say developer will push the code in the GitHub, it will automatically get updated to the AWS. Okay, AWS cloud. So for this, what I have to do, I have to go to my project. Make sure you committed your repository in your GitHub and go to the settings. Okay. Go to the settings. Now here, left hand side, you will see one option called action. Just click on the action, click on the runners. Now create a new self-hosted runner. Now select the Linux machine and you have to execute. These are the commands. So let's copy this command one by one and let me execute here. So it will automatically make the connection with your GitHub. Let me show you. Then the third command, then fourth command, now you have to go to the configuration section and copy this command and execute it here. Now see GitHub action, it will automatically connect. Now it will see it has connected to the GitHub. Now it is asking for enter the name of the runner group. I don't want to give anything, press enter. Now it is asking enter the name of the runner. So here you have to give self-hosted. Okay, self-hosted. This is the thing you have to give. If you're giving another thing, it won't be working. Okay, make sure you're giving self-hosted. Now let's press enter. Now keep it everything default, just press enter again. Then again press enter. Now see, it is done. Now the last command we have to execute this one. And you can ignore this one, it is not required. Now see, it would be connected with my GitHub. See, connected to the GitHub, listening for the jobs. Okay. Now, if I show you, if I come back and now if I go to the runners, let's say, I'll go to the runners. Now see, status should be idle. You can see it is connected. Okay. Now the next thing what I have to do, I have to set up all the GitHub secrets. Okay, now let's go back to the secret. So secret variable, click on the action. Now new repository secret. Now give the secret ID. Okay, so for the first ID I have to give AWS access key ID. Just copy and give the key name here. And why we will get the value, I think remember we downloaded one CSV file. So let me open this CSV file. I will open in a Notepad++. And this is my AWS access key ID. I'll copy. And here let me paste it. Then the next one I have to give secret access key ID, copy. And create another new repository secret and give it here. And in the CSV file you will get the next one. See, it is comma separated. So before the comma, this is the AWS key ID, access key ID, and after the comma, this is the secret access key ID. So let me copy the secret access key ID and I will paste it here. Okay, now the next thing you have to give AWS default region. So region, I already told you I'm inside Mumbai, that means AP South 1. So I think remember, I'm inside AP South 1. See, AP South 1, you have to write it. So let's write AP hyphen South. Okay, hyphen 1, AP South 1. Let's try to check AP South 1. AP South 1. Okay, fine. Now let me add it. Now the next thing I have to add my ECR repo. So ECR repo wise, I think you remember we copied one URL. So just try to get this name only. Okay, after .com, just try to get the name and try to mention here. Then the next thing I have to set my Pinecone API key. So let's copy and add it here. And I think you remember in my .env file I had my Pinecone API key. Let's copy. And this is not available inside my GitHub. That's why I'm reading from the GitHub secret. Okay, this is the idea. Now I also need to add my OpenAI secret. Okay, that means OpenAI API key. The last one you can see OpenAI API key. Let's add it. So let's copy the OpenAI API. Here I'm going to paste it. Now let's add the secret. Okay, now see everything is added. Now let me see anything is left. No, everything I have added. Now what I have to do, I have to push the changes. Okay, but before that, let me get back to my project. Now I'll push the changes. So just try to commit. To commit, just open up your git bash and try to write this command: git add space dot, then git commit -m. Let's say ci cd edit, then git push origin main. Now if I go back to my GitHub, now see if I refresh here, so it will start running my action. Now just go to the action. Now see my action is running. See, first of all, it is running the continuous integration. So inside continuous integration, first of all, it will authenticate with my AWS ECR, build the Docker image, push it to the ECR. Okay, everything will happen. See, automatically. It's just a one-time setup, guys. Next time, you don't need to set up it. You just need to write the code and push it to the GitHub. Automatically, it will push to the, let's say, AWS server. Okay, now see. So let's wait. Once this execution is completed, I will come back. So guys, as you can see, my continuous integration is completed. Now it is running the continuous deployment. Now what it will do, it will again authenticate with my AWS cloud, and it will pull that image from the ECR to EC2 machine. And if you go to the Elastic Container Registry right now, and if you refresh here, you will see the image. Okay, see Docker image is been uploaded here. Now see, it is running the deployment. Now see, it is pulling the image. So once it is full, then we'll doing the port mapping. We'll create the endpoint and we can access our application. Let me show you. So guys, as you can see, my execution is completed. That means both integration and deployment is executed. If you're not getting error, that means congratulations, it's done. Now I will go back to my EC2 machine. Okay. Now here in the EC2 machine, you will get one public IP address. Just let me show you. So this is the public IP address. Just try to copy and just try to open it. Okay. Now see if I open it up. So it won't be opening because see my application is running on port number 8080. I think you remember. Okay. So by default port number 8080 is not set. So I have to do the port mapping. So what I have to do, I'll go back, go to the instance. This is my instance. Then I'll go to the security. Okay. Now here you will see one option called security group. Just click here. Now on top you will see edit inbound rules. Okay, just try to click here. Now I'll just add the rules. Custom TCP port number, just give 8080. Just select 000. Okay, and here you will see save rules. Okay, just click on the save rules. That's it. Okay, so rules has been added. Now I'll go to the instance again. I'll open it up. Now I'll copy the public IP address again, and here let me paste. Now you have to give clone port number 8080. Now see, if I hit enter, my application should be running. See guys, this is my chatbot is running. Now if I give any message, let's say what is acne. See guys, it is giving me the response. Now see, my application is live right now. So it is already deployed. Now user can use my applications. Now what you can do, you can buy a domain, okay, your custom domain, and you can publish this application to the audience. Okay, now for the second time, let's say you changed anything in the code. Let's say you added some more function. What you have to do? Only just need to commit the changes. It will automatically get updated here. Fine. So no need to set up anything from scratch. It's just a one-time setup. Once setup is completed, just try to commit the changes. It will automatically running. Okay. Now you can ask me, if I close this terminal, will it work? Yes, definitely we can close it. Let's say I will close this terminal. Now if I again go to the chatbot, if I refresh, see, still my bot is running. Okay. So that's how guys we can do the CI/CD deployment. Now let me show you how we can terminate all the instance, like whatever instance we created, if you don't want to keep it running, otherwise it will charge you, right? So what I can do, first of all, I will stop the EC2 machine I've created. So select the machine, click on the instance state and terminate. So terminate will delete it, okay? So it will terminate and delete the instance. Then after that, I also need to delete my ECR. So let's go to the ECR. So first of all, delete the image inside that. Just write the delete command. Now try to select and delete. Okay, then what I have to do, I have to delete the then I will also delete my IAM user. Okay, the IAM user I created. User. Let's select and try to delete it. Medical chatbot I have to write here. So let's me copy. And let me delete it. See, everything is deleted. Now nothing will charge you. Okay. So guys, that's how we can perform the deployment. And this is the code. You can use this code as it is. Okay. The code actually have shared. So yes, guys, this is all about, and I hope you liked it. So thanks for watching, guys. And what you need to do, guys, the next project I showed you now that this one, source code analysis, you can deploy this project with the same process. Okay. Whatever project we have created so far, you can deploy with the same process. Thank you so much for watching this video, and I will see you next time.